Okay, so let me see the preparation of phenols now. Some properties are there of alcohols. We will see that one also. Okay, let me see the preparation of alcohols. So first preparation is what actually? Generally, one thing if you remember, phenol generally prepared by, phenol is also called as a carbolic acid, right? The other name, common name of the phenol is what? Carbolic acid. Understood? Carbolic acid also called as phenol. Sometimes it will be useful for you. Phenol is also called as carbolic acid. Next, if you observe this one, commercially it is produced. Phenol is commercially produced, isn't it? From what actually? Coal tar in that one. Phenols are prepared from the benzene derivatives by any following method. So we'll discuss about this method called dose method. This method is called what? Dose method. Shall all of you write down the first method is what here? Dose method here. Now let me see this one. The first method. Now in this case, what we are doing here, we are taking what? Chlorobenzene. On reacting with what? Sodium hydroxide. You can take even potassium hydroxide also. Sodium hydroxide or potassium hydroxide. And drastic conditions we need to maintain. Anybody say why we are maintaining the drastic conditions? Is it why you are maintaining that one? Yesterday only we are discussing this one. This topic only we discussed yesterday only, no? Why we need to maintain a drastic condition here? Yes. Are you there? Are you there here or not? Is my voice is audible?
Yes,
Then
sir.
why you are not responding here? Yesterday only we discussed why halobenzenes, isn't it? Unable to do this reaction. Anybody? Yesterday means what? In the last classes, I think. Yes. What is the reason?
Because of
Three
resonance.
reasons I told you. I told three reasons by using NCERT textbook only in that day also. Okay. So what is the reason in that case? We may get double bond character, isn't it? We may get here double bond character here, isn't it? We may get here double bond character like this here, or this is sp2 carbon. Resonance is possible. So that is the reason actually. So the temperature we are maintaining 623 Kelvin, 300 atmosphere. Roughly you take 300 atmosphere pressure. So the reason behind this one, what is the reason? Nucleophilic substitution reactions, isn't it, on halobenzenes is difficult. Halobenzene is difficult. If you get a question like this, why nucleophilic substitution reactions on halobenzene is highly difficult? What is the reason you say here? Very simple. Because the halogen and double bond carbon will get double bond character, and sp2 carbon Cl bond length is shorter bond length, isn't it? And because of what? The excess of electrons over the benzene, pi electron excess. These are the three reasons why the halobenzenes are not undergoing nucleophilic substitution reaction. So this reaction is called now nucleophilic substitution reaction. This is called what? Nucleophilic substitution reaction. So what is the reactant here? Chlorobenzene. This is called chlorobenzene. On reacting with sodium hydroxide in presence of drastic conditions, first of all, what happens here? So this ONA part you write here in the place of what actually chlorine, write down the ONA part. Remove the chlorine because substitution reaction. No, substitution means what? Remove one substituent and replace with another substituent. So remove the chlorine, replace with sodium oxide. You will get like this. Okay. After that, when you do hydrolysis, this part will be broken here, and you will get hydrogen here. And you will get here OH. So you are going to get the phenol like this. So this is important one. Dose method. We call this one. Okay. From haloarenes, chlorobenzene is fused with what? Sodium hydroxide, isn't it? It's used with what? Sodium hydroxide. At what temperature? 623 Kelvin, 300 atmosphere pressure. We are going to get the phenol is obtained. Middle what we get here? Sodium phenoxide. This is called actually what? Sodium phenoxide. This is called what? Sodium phenoxide. ये reaction आपको थोड़ा practice करना है. Next, second preparation method, if you observe it, we'll take here again benzene we are taking, okay, aromatic compound, reacting with what here? Oleum. Oleum is what? Anybody? Oleum is what? What's the meaning of oleum? Anybody? What's the formula of oleum? H2S2O7. Oleum. Now this oleum, when you do hydrolysis, you will get 2 moles of sulfuric acid. Okay, oleum, when you do hydrolysis with what? Water, isn't it? You will get sulfuric acid. So from that, what happened? From the oleum, SO3H part will substitute over the benzene. That means in the place of hydrogen here, no, in the place of hydrogen, we are going to get the SO3H part. After that, again do the basic hydrolysis. Here it is what? Basic hydrolysis. If you do what happened, that means what? Adding some base, then again what? Add H plus here. Now what happens here? This will be broken. Now this NaOH and SO3 will be removed as NaHSO4 here, NaHSO4, and we are going to get the OH. So this is by what? Benzene is sulfonated. So adding SO3H to the benzene is called what? Sulfonated. Adding SO3H to the benzene is called sulfonated. What is the reagent we are using here? Oleum we are using here. And we are going to get this one. This part is what actually? Benzene sulfonic acid. Okay. This part is what we are calling benzene sulfonic acid. Now this is converting into phenol. How? By using what? Sodium, isn't it? Hydroxide. By using what? Sodium hydroxide. This is what? Sodium hydroxide is. On heating with molten this sodium hydroxide, we are going to get what? Phenol. In this way, we can leave it this sodium phenoxide. Actually, sodium phenoxide will form, but leave it directly. You can write this reaction. Okay. How you write this one? Take first of all what? Benzene, right? Then treat this one with oleum. After treating with oleum, what we get here? Benzene sulfonic acid. Benzene sulfonic acid. Okay. Now this is on hydrolysis. Okay. What we are going to get? The phenol. So this is the theory part. Now when you write this part, actually how you write? Take benzene, take H2S2O7, write on the benzene sulfonic acid structure like this, treat with what? NaOH and H plus, we get the phenol actually. Okay. Next what happened? We'll see from diazonium salt. This is very important for the conversions. From diazonium salt, isn't it? That is very, very important for us in the conversion. So how do we get a diazonium salt? Take aniline. You know aniline, what is aniline? When you place OH on benzene, that is called phenol, right? When you place OH on benzene, that is called actually what? Phenol actually, okay? But when you place what? NH2 over the benzene, that is called what actually? Aniline. So what is the meaning of aniline here? Place NH2 on benzene, that is called aniline. Place OH on the benzene, that is called phenol. So now do reaction with sodium nitrite, isn't it? This is called what? Sodium nitrite. Sodium nitrite, isn't it? Plus what happened? HCl. Plus HCl. Otherwise what happened? You take what? When NaNO2 and HCl both react, what happened? We get HNO2 also. So directly you can treat with HNO2 also. So in examination, they may give in 2 ways actually. They may give in 2 ways. What is that way they are giving actually, if you observe what happened here? That means they may give like this actually. I'm writing here first of all. Whatever I'm writing, is it visible for you?
Yes, sir.
Yes, sir.
Right. Is it taking some time? Otherwise, it is just coming spontaneously. Is it coming or not taking some time?
Coming, sir.
Okay, no problem. HNO2 if they given, or if they given, what happened? NaNO2 plus HCl. Okay. Now take from this one HNO2, NaNO2 HCl. Take from this one HNO2. Now we are getting HNO2. That is, it is in situ. In situ means what? Within the reaction it will form. So when you actually, you need to know, you don't have HNO2 actually. HNO2 is not available for us. But what we have to do, we have to take sodium nitrite in presence of HCl. If we take what happen, immediately it will form HNO2. That HNO2 react with aniline. So in examination, if they given HNO2, nitrous acid, or if they given what actually NaNO2 both are same. Don't get any confusion here. Okay, what I am saying understood here. In examination, if they given nitrous acid, please all of you open your notebooks. Better to understand what happened. You just open your notebook here. Okay, and otherwise what happened? NaNO2 plus HCl. NaNO2 plus HCl. The page number is 324. Just see the page number also there. So at what temperature you have to maintain something? What happened? 4 degrees Celsius. Roughly what happened? What is the temperature you have to maintain here? 0 to 4 degrees Celsius you have to maintain. Otherwise what happened? This will undergo decomposition reaction. So that is the reason maintain 0 to 4 degrees Celsius. Now whatever you are going to get, benzene diazonium chloride. Where you got? Anybody have remember this product? Have you remember this product? Where we got? In the preparation of which one we got this one? Anybody? You have any name or reaction is there for this one? For benzene diazonium chloride, do you have? Very good. Sandmeyer, or even you can take Gattermann reaction. In Gattermann-Sandmeyer reaction, we have prepared what? Chlorobenzene and bromobenzene, right? Here, in place of that Gattermann-Sandmeyer reaction, now I am taking what? Water here. By taking some water and simply warming that. Okay, take in the test tube this benzene diazonium chloride, add some water and heat that one. So immediately what happens? You are going to get the phenol here, and the nitrogen and Cl we get from here. This one you are getting nitrogen here. From the water, what happens? We get OH from this one, and H plus Cl will be removed. Actually. So this is very important one for what actually? Preparation of what? Phenol, and it may be useful in the conversions. Okay. So third method is what actually? What is the third method? So from benzene diazonium salt, you are getting phenol. How we are getting from benzene diazonium salt or phenol? By treating with water and heating. Okay, the treating with water and heating, you got this reaction. Understood here? Okay. Any doubts you're having in the third reaction? Anybody having any doubts here? No doubts. Right. Now we'll move to what next? The fourth one, the last one, if you move from cumin. From cumin. What is cumin? Let me see now. What is the meaning of the cumin? Let me see. Now cumin means very simple. I will write in this manner. Everyone knows isopropyl group. Isopropyl. Anybody know iso means what actually? Second carbon is having methyl. This is isopropyl, but something it is having what? Anything it is having something benzene. You just take as a benzene. Completed it is. Isopropyl benzene. Simply called as what? Cumin. Iso means आपको पता है ना, second carbon is having what here? Methyl group here. That's it. Remaining is a straight chain. Yes, it is a straight chain only. Correct. Now this is called actually what? Cumin. What is the IUPAC name? Anybody? Anybody? What is the IUPAC name? What is the IUPAC name of cumin? Isopropyl benzene is a common name. Even cumin also what? Commercial name. Cumin is a commercial name actually. Isn't it? Now tell me what is the IUPAC name? Is it possible? Anybody? बहुत मुश्किल है. Is my voice is audible for you? जो मैं बोल रहा हूं आपको सुनाई दे रहे हैं? नहीं सुना दे रहे? Are you there or not? Yes?
Yes, sir.
अरे भैया कुछ तो बोलो ना. ये सभी लोग क्या सो रहे हैं? मैं आपको आपसे पूछा IUPAC नॉमेनक्लेचर पूछा. अब बुक देख रहे हैं? नहीं तो फिल्म देख रहे हैं?
Yes, sir.
What is सर? देख रहे हैं टीवी? टीवी देख रहे हैं आप? टू बेंजीन बोलते हैं इसको, टू फिनाइल बोलते हैं बेटा, टू फिनाइल बोलना है इसको, ठीक है ना। बेंजीन कब बोलते हैं आपको, अगर बेंजीन है ना इंडिपेंडेंट है तो बेंजीन बोलना है इसको, इसके पास कुछ नहीं है, उसको क्या बोलते हैं, बेंजीन बोलना है। अगर बेंजीन किसी से साथ अटैच हुआ उसको क्या बोलना है आपको, फिनाइल बोलना है। फिनाइल का मतलब क्या है, अगर
टू
बेंजीन
बेंजीन
किसी से अटैच
प्रोपेन।
होता है ना उसको क्या बोलेगा आपको, फिनाइल बोलना है, इजंट इट। अगर आप अब देखिए वुमेन, शी इज इंडिपेंडेंट, अगर किसी से मैरिड हो तो क्या बोलते हैं उसको, वाइफ बोलते हैं। वाइफ का मतलब शी इज व्हाट जॉइंड विथ व्हाट सम अदर्स लाइफ, हियर बेंजीन इज इंडिपेंडेंट, but phenyl means what, it's a substituent. Benzene is what, as a substituent what happen, then it's called what, phenyl. तो आपको क्या बोलना है इसको, टू फिनाइल प्रोपेन, टू फिनाइल propane, understood, right? Because in sometimes what happen, if they give IUPAC nomenclature, if you don't know that one, no, in conversion if they give what happen, so if they give IUPAC nomenclature, 2-phenyl propane is something reacting with oxygen and H plus, what is the product they given, what happen in that case, what happen, if you know the IUPAC nomenclature is a better one. Okay, so 2-phenyl propane it is. Now how we are writing the reaction, I am writing here, now I am writing here, if you observe here, अगेन आई एम राइटिंग द बेंजीन, बेंजीन को छोड़ दो, बेंजीन पर कोई रिएक्शन नहीं होगा आपको, ठीक है ना, बेंजीन को छोड़ दो उसको। सो रिएक्शन कहाँ हो रहा है देखना है, CH3, okay, this CH3 I am writing, shall I write like this, just a minute, I am writing as a pH, no problem, no कोई प्रॉब्लम है तो ऐसे pH लिखने तो, is anybody facing some problem if I write pH3 there here, both are same or not, this is cumene or not, tell me beta, cumene only, in the instead of writing the ring, just written actually pH only, pH is nothing but phenyl group here. Now when you do what, oxygen with oxygen, when you do oxidation with oxygen, what happens here, no, this oxygen will settle between the carbon and hydrogen, understood. Now, what is happening here in cumene, when you do with oxygen, when you do with oxygen, what is happening in the cumene, tell me better, the
No, sir.
oxygen is settling between what, carbon and hydrogen. तो
Yes, sir.
देखिए आप एक बार देखिए क्या आएगा, CH3 सेम लिखना है आपको, ऐसा ही लिखना है, CH3 ऐसा लिखना है आपको, एंड बॉटम में pH लिखना है। तो बिटवीन कार्बन हाइड्रोजन यू पुट व्हाट, O2 में कितना ऑक्सीजन होता है बेटा, O2 में कितना ऑक्सीजन होता है, ऑक्सीजन हो जाएगा, है ना, सभी बोलो ना, 2 ऑक्सीजन हो जाएगा। तो बिटवीन कार्बन एंड हाइड्रोजन O2 is getting it. So you are getting this one. This is called peroxide. Whenever if you get over linkage, no, this is called what, peroxide. You are getting it. Peroxide. बाद में आपको क्या करना है, very simple. After this, what we are doing? You do what, hydrolysis reaction. Do what, acidic hydrolysis. H plus and what? What is the meaning of acidic hydrolysis? In water, add some acid and treat that one with what, whatever the intermediate you got. यहाँ पर क्या होता है, मैं यहाँ पर आपको एक लिखता हूं, मैं बेंजीन लिखता हूं, तो थोड़ा आसान होने के लिए मैं क्या लिखता हूं यहाँ पर, बेंजीन लिखता हूं। देखो बेटा ये आपको थोड़ा ये सेव नहीं हो जाएगा, अगर सेव ये कंप्लीट होता आपको लिखना है, आपको नोटबुक में लिखो ऐसा, क्योंकि ये टेक्स्ट बुक में इतना एक्सप्लेनेशन नहीं हो जाएगा, आपको डायरेक्टली हो जाएगा ना टेक्स्ट बुक में आपको। तो आपको क्या करना है यहाँ पर, देखो ये OH है ना, यहाँ पर 2 OH है ना, इस OH को आपको कहाँ रखना है, निकाल कर यहाँ पर रखना है, देखो यहाँ पर रखना है, और ए बॉन्ड रहते हैं ना, ए बॉन्ड, इस बॉन्ड को आपको यहाँ पर रखना है। तो आपको क्या हो जाएगा यहाँ पर, यू आर गोइंग टू गेट, इज इट विजिबल फॉर यू, व्हाट आई एम राइटिंग इज विजिबल,
Yes, sir. Yes.
Yes, sir.
Yes, sir.
next this part will convert into what, actually CH3, okay, CH3. Now you consider this one, now already one bond is there here, already one bond is there, now this bond also shifting here, so it will convert into what here, this bond, acetone we are getting, acetone, and आपको ये पता है ये क्या है, फिनोल है। तो ये प्रैक्टिस करना है आपका, ये वेरी वेरी इंपॉर्टेंट रिएक्शन है, फ्रॉम क्यूमीन गेटिंग फिनोल, कैसे करना है? पहले आपको क्यूमिन लिखना है, क्यूमिन को प्रैक्टिस करना है, बाद में treat this one with oxygen. When you treat with oxygen, what happen? Between carbon and hydrogen, place oxygen like this. Between carbon and what here? Hydrogen. Here. You are placing what actually? Two oxygens like this. After this OH part put on the benzene, okay, and this bond you shift here, you are going to get the phenol. थोड़ा ये प्रैक्टिस करो, नोटबुक में लिखो ऐसा, तो आपको प्रैक्टिस हो जाए। नहीं तो ऐसा प्रैक्टिस करे तो नहीं आएगा, क्योंकि यहाँ पर डायरेक्टली दिया उसने डायरेक्टली दिया यहाँ पर। अंडरस्टूड यार? ये आप नोटबुक में, टेक्स्ट बुक में इसने डायरेक्टली दिया इसको, है ना? तो आपको यहाँ पर क्या करना है? आपको दिस OH पार्ट कहाँ रख रहे हैं आप? बेंजीन के ऊपर रख रहे हैं, बेंजीन के ऊपर रख रहे हैं, और दिस पार्ट इज कन्वर्टिंग इनटू एयर लाइक दिस. So this is called what? Preparations of phenol. 4 preparation phenols are completed. One is from haloarenes, from benzene sulfonic acid, from diogenem salt, and from the purine. 4 preparation methods. So in examination, they may ask like this, write 2 preparation methods for the phenol, otherwise something or directly reactions. Okay, this what happened? We have completed the preparations of phenols here, right? Now, in this case, show how the following alcohols prepared by the reaction suitable Grignard reagent. ये आपको पता है? कोई कर सकते हैं क्वेश्चन? Is it possible for you? मैं एक लेता हूं, दूसरा आप ले लीजिए, है ना? दूसरा आप ले लीजिए. Okay. Now, the suitable Grignard reagent on methanol. So, what they are saying here, you have to take methanol. Right? Compulsory, you have to take methanol. Okay? Very simple it is. It looks what very difficult, but we can make that one into very simple like. So the carbon compound must be methanol only. From this, we need to convert this one into CH3, CH, CH3. Next, what happens? CH2. How do you do this one? How do you do this one? Which Grignard reagent we are taking? What is the R group in this case? Anybody? Anybody is possible? Anybody can do this one? तो आपको यही वेरी सिंपल मैं बताऊंगा, जो उसने दिया उसमें CH2O को छोड़कर रिमेनिंग आपको R से लेना है, R जैसा लेना है, R जैसे लेना है. तो R जैसे ले लो यहां से CH3, CH, CH3, MgX, MgX. Now this part will be what actually? Tell me better. This part will be what actually? RMgX, RMg. Whatever I'm writing, is it visible for you?
Yes, sir.
Right.
Yes, sir.
Now this part will become as R group here. Correct? Now this part we can write like this, CH3, CS, CH3. Answer is completed here. Otherwise, you try this one, you attach here. Yesterday we discussed. थोड़ा आपको प्रैक्टिस करना है, जो हमने क्लास में मैंने बताया ना, थोड़ा उसको प्रैक्टिस करना है आपको, नहीं तो नहीं आएगा ऑर्गेनिक केमिस्ट्री. रोज प्रैक्टिस करना है. नहीं, इसको देखो, इसको क्या करना है? आप RMgX क्या बोलते हैं इसको? तो आपको क्या देखना है? CH2OH, मिथेनॉल दिया ना उसने, CH2OH को छोड़कर रिमेनिंग क्या होता है यहाँ पर? R हो जाएगा. तो इसमें आंसर क्या है? ये हो जाएगा आंसर, साइक्लोहेक्साइल Mg. आंसर हो गया. मैं एक बार लिखता हूं, लिखकर आपको बताऊंगा इसको. ये ग्रिग्नार रिएजेंट है, ठीक है ना? MgBr, RMgX, राइट? ग्रिग्नार रिएजेंट है ना या नहीं? बोलो, is it Grignard reagent or not? बोलो बेटा.
It is, sir.
करेक्ट है ना? cyclohexyl magnesium bromide is a Grignard reagent. Correct? R. This is nothing but R only. Right? Now this part attacking where on the C double bond group. Now what we are going to get here? Cyclohexyl. Correct. Next what happens? CH. Here also. What we are going to get? बाद में आपको क्या करना है? इसको H, इसमें H+ ऐड करना है. H प्लस ऐड करने तो यहाँ पर H आएगा आपको, तो ये हो जाएगा आपको, ठीक है ना? वेरी सिंपल और नॉट? फॉर एग्जाम्पल आई विल गिव वन क्वेश्चन टू यू, आई विल गिव वन मोर क्वेश्चन टू यू. अगर आपको ए लिखना है, CH3 CH2 CH2OH, तो इसमें ये आने के लिए मैंने फॉर्माल्डिहाइड लिया. व्हाट इज द ग्रिग्नर रिएजेंट फॉर दिस? टू गेट दिस वन, व्हाट इज द ग्रिग्नर रिएजेंट? एनीबॉडी? द नेम ऑफ द ग्रिग्नर रिएजेंट, टेल मी, डू फास्ट. फॉर गेटिंग दिस प्रोडक्ट, what with what methanol, what is the Grignard reagent? CH3 CH2 CH2OH.
Ethane.
Ethane. Ethane.
इथाइल मैग्नीशियम
Ethane.
हाँ, ईथेन नहीं है, इथेल. इथेल मैग्नीशियम ब्रोमाइड है वो, है ना? किसने दिया जवाब? वनिता, कौन, किसने दिया? इथेल मैग्नीशियम ब्रोमाइड किसने बोला?
सर इथाइल मैग्नीशियम हैलाइड दिया था सर.
नहीं, किसने बोला?
सर वनीता.
Vanita only. Very good. Very good. Ethyl magnesium bromide. You practice these questions, isn't it? 11.4 type of questions you practice. May be useful in the NEET also. This type of questions will be NEET also. It will be useful. Okay. Right. This is 11.4. You have to write entire the chemical. Don't write what happened answer. By seeing what happened, you will get many market. You will get some what happened solution books. So they will give you directly what happened the answer. In order to make the printing cost less, what happened? They give directly answer here. So what you do, you take copy that answer. In that way, you don't get anything. You have to write with what the mechanism we have given here. This is the mechanism we have given. This is the mechanism we have given. So with this mechanism only, you have to write this. Okay. And what about the 11.5? Is it possible now for you? 11.5 is possible. 11.45 is possible for you. 1 is possible. One is possible for us.
Yes,
Preparation
sir.
of alcohols from alkene. This is what actually what? Preparation of. This is what actually what? Preparation of what? Alcohols. From what? Alkene. ये आपको लिखना है कंपल्सरी. ये क्या है? रिडक्शन करना है इसको. रिडक्शन NaBH4. This is it is there here. एस्टर्स ग्रुप यहाँ पर है, ये है. इसमें आपको क्या करना है? यहाँ पर ब्रेक करना है आपको. ब्रेक करके इसको आपको क्या लिखना है? ROH लिखना है. इसको आपको क्या लिखना है? CH2OH लिखना है. इसको मैं इधर बताऊंगा, यहाँ पर बताओ. देखिए यहाँ पर क्या होना है? यहाँ पर आपको ब्रेक करना है. इसमें क्या होता है? आपको CH3OH आएगा. यहाँ पर क्या करना है आपको? यहाँ पर ये पूरा एक पाई बॉन्ड आपको ब्रेक करके यहाँ पर एक हाइड्रोजन लगाना है और यहाँ पर भी एक हाइड्रोजन, 2 हाइड्रोजन लगाना है. तो आपको क्या हो जाएगा यहाँ पर? तो आपको now one more thing, here also C double bond O group is there. No, you will get here what? OH. Wherever C double bond O group is there, there will get OH or not. You have seen this reaction here. You observe this reaction one more time here. You get any doubt here? You will observe this one. Preparation of alcohols. You see this one. Wherever CO is there, we got CHOH. Yesterday we discussed these topics actually. Wherever OH is, CO is there, that will convert into CHOH. What? NaBH4 here. Okay. Now here, the product we are going to get here actually what? In this case, just in this case actually, what product we are going to get here? Now I am write something here. Now the C double bond O group is there no here? Yes, C double bond O group is there here. Now this C double bond O group is converting into OH here. Now this part will remain like this only. Don't do anything on over this part. Okay. If they given lithium aluminum hydrate, you can convert this into CH2 CH2OH, and this will convert into CH3OH actually. But here no need to do anything actually. Now NaBH4 again they given. Now wherever C double bond O group, that will convert into COH. So already CH is there. So this will convert into CH3, CH2, CH3 and CH2OH. Reduction. या ये एक्चुअली एप्लीकेशन पार्ट दिया, थर्ड क्वेश्चन एप्लीकेशन पार्ट दिया। देखो यहां पर देखो aldehyde CHO converting into what here? CH2OH. Only what is changed here? Reagent. So yesterday only I discussed NaBH4, lithium aluminum hydride, or hydrogen in presence of platinum, palladium, nickel, isn't it? Finely divided, isn't it? This catalyst and what hydrogen, isn't it? Doing what actually? RCHO into what actually? RCH2OH. yesterday हमने डिस्कस किया है इसको, मैकेनिज्म भी डिस्कस किया। RC double bond O R, this part, RC double bond O R, this part will convert into what है? RCR, यहां पर आपको क्या आएगा? OH and हाइड। इसका मैंने मैकेनिज्म कल दिया आपको। तो कितना रिएजेंट आपने लिया? यहां पर 3 रिएजेंट लिया है। फर्स्ट इज व्हाट एक्चुअली? हाइड्रोजन इन प्रेजेंस ऑफ प्लैटिनम और पैलेडियम और निकल। सेकेंड रिएजेंट क्या लिया हमने? लिथियम एल्यूमिनियम हाइड्रेट। थर्ड क्या लिया हमने? NaBH4 लिया। These are the 3 reagents which convert RCHO into RCH2OH, RCOR into RCHOR। मैंने इसका मैकेनिज्म कल एक्सप्लेन किया। इसका इसने क्या किया? इसका थोड़ा इम्प्रोवाइज किया सब थोड़ा, by taking what some application part for this one. So this is entire the group is what actually here? R group. This is what everything is what? RCHO. Okay, this part is R actually. This part is R. CS3, CS2, CS, CS, R. Remaining is CHO. So ये क्या हो जाएगा आपको? CHO will convert into what here? CH2OH. Answer is complete. Whatever they will give, leave it that one. कहां पर CHO है वो आपको कन्वर्ट करना है into what? CH2OH actually. This is actually what that in-text questions actually what we have discussed. Next, if you see what physical properties. Now let me move to what here? Some physical properties actually. Now when you observe what happened physical properties here, now alcohols are, even if you consider alcohol or phenols, you take alcohol or phenols, whatever you take it, they're having 2 parts. One part is what? Alkyl or aryl group. So this part, aryl group, this part is called what? Aryl group. And if you consider alcohol, this part is what actually? Alkyl. Okay, for example, I'm writing ROH. This is called alcohol. Alcohol it is. Now alcohols are having what type of group actually? Alkyl part. Okay. Phenol. Phenol is what having it is this part. Phenol it is. Now this part is called as what? Aryl group. So what I'm saying here, alcohols and phenols consist 2 parts. Alcohol contains alkyl group, whereas phenol contains here aryl group. And both are having the second part is what here? Hydroxyl group. Both are having what? The second part is what? Hydroxyl group here. Both are having hydroxyl group here. Both are having hydroxyl group. So one part is what? Either alkyl or aryl. Second part is what? Hydroxyl group here. Now when you observe what happened, whatever the properties if you observe here, that is not because of the R here, not because of alkyl, not because of aryl here. The second part is actually making the reactions. Okay. So here the hydroxyl group is the second part. This is the main reason. The hydroxyl is the main reason for undergoing the chemical reactions. Understood here? So what I'm saying here, both are having what? Hydroxyl parts, alkyl and aryl. The main properties of these groups because of what? Hydroxyl groups only. Next, if you observe what happened, boiling pans. Boiling pans are very important for us in physical properties. Now, how boiling pans are increasing here? When number of carbon atoms are increases here, molar mass will increases, molecular weight increases. When molecular weight increases, what happen? Van der Waals forces also increases. Van der Waals forces will depends upon what character? Molecular weight actually. So more molecular weight, more Van der Waals force. So the boiling pans will depends upon here what? More number of carbon atoms. So if you observe what happened, phenol and normal alcohol, phenol is having more molecular weight, therefore phenol will have more boiling point. For example, if I take methanol and ethanol and propanol, which will have more boiling point? Better bolo jaldi bolo. Methanol, ethanol and propanol, which will have more boiling point?
Propanol.
Whichever is having more number of carbons, that will have more boiling point actually. So that is very simple. Points will decreases with increasing of branching in the carbon chain actually. So what is the meaning of this? What is the meaning of this part actually? I'm writing here this. Branching increases, what happened here? Boiling point decreases. So shall I write like this? Branches, more branches, less boiling point. I'm writing this one. Okay. Shall I take one example here? CH3, here I'm writing. Shall I write here? Here I'm writing CH3, CH2, CH2, CH2OH. Okay, this is the first one. Butanol, one butanol, right? Second one I'm writing here CH3, CH, CH2OH. Here I'm writing about CH3. This is the second one. Isobutanol, right? Or butyl alcohol, isobutyl alcohol. Third one I'm writing here CH3, 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 OH. This is called tertiary butyl alcohol. So the name of this one is called tertiary butyl alcohol. Tertiary butyl alcohol. This one is what? Isobutyl alcohol. Many number of times I explained this one. This one is what? Butyl alcohol. N-butyl alcohol. N for what? Straight chain. N-butyl alcohol. Now tell me which will have more boiling point based upon this one. Based upon this one. 1, 2 or 3?
1.
First one.
1.
N-butyl alcohol.
What happened? There are no branches. Everything is straight chain. When you have straight chain, what happened? We can arrange them in one, a long, large we can arrange. But if we can't arrange more in this case, what happened? No. Packing efficiency will be less. There will be more space, empty space will be there, isn't it? If you arrange this type of molecule in the box, what happened? Empty space will be more in that case. In that case, what happened? Less molecules will be available. But in this case, what happened? We can arrange many number of molecules in the box. So definitely what happened? You remember this one. As branches increases, what happened? The boiling point will increases. Now, one more thing here. Interhydrogen bonding. Interhydrogen bonding or intermolecular hydrogen bonding. Now, what is the meaning of intermolecular hydrogen bonding? There will be electrostatic force of attractions, isn't it? Between the more electronegative element and hydrogen of another molecule is called what actually? Hydrogen bonding. Let me see this one. I'm just erasing here. इसको मैं रफ करता हूं तो आपको लिखो नोटबुक में लिखो ब्रांचेस विल इनवर्सली प्रोपोर्शनल टू व्हाट बॉइलिंग पॉइंट ये बुक आप नोटबुक में लिखो और ये भी लिखना है आपको ये भी लिखना है ये ऑर्डर भी लिखना है ऑर्डर क्या हो जाएगा ग्रेटर देन हो जाएगा नाउ नेक्स्ट थिंग व्हाट आई एम सेइंग हियर यू ऑब्जर्व हियर व्हाट आई हैव टेकन समथिंग alcohol R OH I have taken and here I am taking one more alcohol in the reverse manner like this both are same only right now between oxygen and hydrogen some electrostatic attractions are present this you are calling as intermolecular isn't it hydrogen bonding now in the phenol also what happened this is possible just like in the place of R what we can take pH here pH is nothing but what phenyl group here you can get same hydrogen bonding whatever you are getting in the alcohol phenols are also getting what here hydrogen bonding here also you are getting our same hydrogen bonding that is what interhydrogen bonding Now, what do you observe here? What happened? Now, when you compare the boiling points of alcohols and phenols, which are higher when you compare with what happened? Hydrocarbons, ethers, haloalkanes, haloarenes, whatever we discussed until now. Whatever we discussed until now, which is having higher boiling point beta? Which are having higher boiling points? Which are having higher boiling point? Sleeping. आपको अचानक
alcohol and phenol.
सब लोगों को which are having what? Alcohols and phenol. You just go to doctor because many of you are getting sleep while you're listening to the class. Isn't it? That is not good sign for health. Right. You take one example here. Ethanol, alcohol. Correct or not? Isn't it? Ethanol, alcohol. This is ether actually. Methoxyethane is a ether. This I am writing here. Alcohol. This one is what actually? Ether we didn't discuss now. Just take the molecule. This is what actually alkane actually. Correct or not? Correct or not? Alcohol, ether, alkane. कुछ तो बोलो बेटा.
Yes, sir.
कुछ तो बोलो. मैं ऐसा लग रहा है कि फॉरेस्ट में जाकर मैं ऐसा आपको ऐसा सुनाई दे रहे हैं. क्लास बोल रहा है ऐसा लग रहा है मेरे को. Now, which will have higher boiling point beta? Alcohol, ether, and alkane. Alcohol, ether, alkane.
Alcohol.
Alcohol will have more boiling point than compare with ether. The reason behind this one, alcohol can form here hydrogen bond. Alcohols can form here hydrogen bond actually. Correct or not? Now, in this case, the condition is that their molar mass must be equal, near to equal. For example, if you observe the ethanol molar mass is 46, okay, and ether molar mass is given here 46, and propane molar mass is near to what? 46. So not I am saying exactly 46, no, it should be near. So when you are doing this type of questions, what you have to do? They are having near molar mass. Then only this will work actually, right? Now you observe this one, 11.3 example if you observe, 11.3 example if you observe what is happening. Arrange the following sets of compounds in order of increasing of boiling point. तो यहाँ पर आपको सभी अल्कोहल दिया इसने, सभी all are what alcohols in, right? All are what alcohols only. All are what alcohols. All means what? All means alcohols only. Now आपको क्या देखना है इसमें? पहले क्या देखना है आपको? बोलो बेटा, दो कंडीशन आपको देखना है इसमें. ये में क्वेश्चन नंबर ए में आपको दो कंडीशन देखने हैं. फर्स्ट कंडीशन क्या है? एनीबॉडी? नंबर ऑफ कार्बन्स. ठीक है ना? नंबर ऑफ मोर कार्बन्स, मोर बॉइलिंग पॉइंट. यू ऑब्जर्व हियर मिथेनॉल. हाउ मेनी कार्बन्स डेटा? मिथेनॉल में कितना कार्बन है? मिथेनॉल में 1. वेरी गुड.
1.
वेरी गुड. नाउ इथेनॉल, हाउ मेनी कार्बन्स बेटा इसमें? 2 carbons. Now boiling point is increasing now. Methanol to ethanol boiling point is increasing now. Now propanol कितना कार्बन है इस पे? 3 कार्बन है.
3.
ब्यूटेन में कितना है अभी? 4 है. यहाँ पर भी ब्यूटेन दिया है इसने. मिस्टेक दिया है. ये मिस्टेक है. दोनों पे ब्यूटेन दिया है. Is it called mistake? Is it? No. It is 1 ol. It is 2 ol. They're having some branches here. Now here it is having 4 carbons, and here also it is having 4 carbons. Now it is having what? 5 carbons. Which one? Pentanol. Having how many? 5 carbons. Now there is no problem here. One methanol having less boiling point than ethanol. Ethanol is having less boiling point than what? Propanol. Propanol is having less boiling point than what actually? Butanol. And butanol is having less boiling point than pentanol. But thing is that what happens between the butane 1-ol and butane 2-ol? तो आपको क्या लिखना है? इसको स्ट्रक्चर लिखना है. मैं पहले क्या लिखता हूं? ब्यूटान 1-ol लिखता हूं. ब्यूटान 1-ol लिख रहे हैं. CH2CH2OH. ब्यूटान 1-ol मैंने लिखा. ठीक है ना? ये ब्यूटान 1-ol है. स्ट्रेट चेन है. इसको नेशनल हाईवे स्ट्रेट चेन है ना. नेक्स्ट सेकंड है क्या है सेकंड? CH3 CH2 CH CH3 एंड इट इज व्हाट OH। ना किस पे ब्रांचेस हैं? 1 होल में और 2 होल में ब्रांचेस हैं बेटा?
2 all.
2 होल में ब्रांच है इसका, एक घाट रोड है सेकेंड वन। तो फर्स्ट में नेशनल हाईवे स्ट्रेट, तो आई जस्ट आई टोल्ड यू नंबर ऑफ ब्रांचेस inversely proportional to boiling point. So second is having branches, therefore boiling point will be less. So that is the reason what happened, butane 2-ol is having less boiling point than what? Butane 1-ol. बराबर है ना? मिथेनॉल 1 कार्बन, इथेनॉल 2 कार्बन, प्रोपेनॉल 3 कार्बन, ब्यूटेनॉल 4 कार्बन, ब्यूटेन 1-ol 4 कार्बन, बट ब्रांचेस हैं इसके तो लेस बॉइलिंग पॉइंट, ब्रांचेस नहीं है तो ज्यादा बॉइलिंग पॉइंट। इसमें कितना कार्बन है? 5 कार्बन। This is first one. Second step, how they ask? You have to take what? Functional group here. Second में क्या दिया एक्चुअली देखो यहाँ पर, ये अल्कोहल है, ये क्या है एक्चुअली? अल्कोहल। ये क्या है? अल्केन है। ये क्या है? एल्डिहाइड है। ये क्या है एक्चुअली? ईथर है। तो आपको ऐसा लिखना है अल्कोहल अल्केन, ब्यूटेन इज व्हाट? अल्केन, having less boiling point than ethers. Ethers are having less boiling point than what? Carbonyl compounds. Carbonyl compounds हमके बाद में आ जाएगा, कोई बात नहीं, carbonyl compounds, and they're having what? Alcohols. Alcohols are having more boiling point than the carbonyl compounds. Carbonyl compounds are having more boiling point than ether. They will come in next studies we get. Highest will have carboxylic acids. Even alcohols will have less boiling point than carbon. That is different here. We'll discuss that one later. Okay. Like with this, what happened? What we completed here? Physical properties, boiling point, we have completed. Now let me see something about solubility. Something about the solubility. तो ज्यादा कुछ नहीं रहेगा. Now if you observe what happened, both in water, you observe this is a water molecule, correct or not? Water. Now this part is what actually? Tell me beta. This part is what actually? Anybody? This part is what? This is water. I know everyone knows this from water.
Propanol.
This is what? Alcohol part, right? Propanol or alcohol part? Propanol. Now, water and alcohol will form what type of bonding? When you observe this one, which bonding is possible between water and alcohol? मैं इधर लिख रहा हूं, ऊपर लिख रहा हूं, देखो बेटा, ये वाटर है, ये वाटर है, और ये क्या है एक्चुअली? एक मिनट, जस्ट अ मिनट, आई एम राइटिंग, ये अल्कोहल है, दोनों में क्या बॉन्डिंग हो जाएगा? देखो,
हाइड्रोजन बॉन्डिंग।
हाइड्रोजन। हाँ, दिस इज द रीजन, दिस इज द रीजन alcohols are readily soluble in water, isn't it? Alcohols readily soluble in water. आपका पेरेंट्स वो वाटर डालकर पीते हैं ना, वो रेडीली सॉल्युबल होता है नहीं होता है? इसमें जो अल्कोहल में वाटर ऐड करते हैं ना, रेडीली सॉल्युबल हो जाएगा नहीं हो जाएगा? नहीं हो जाएगा। बिकॉज ऑफ व्हाट इज द रीजन? आपको बोलना है क्या, क्या रीजन बोलना है आपको सॉल्युबिलिटी में? बिकॉज ऑफ हाइड्रोजन बॉन्डिंग alcohols are readily soluble in water, isn't it? Now the solubility with increasing the size, if you observe what happened, the solubility will decreases here. What is the reason here? For example, if I take some, shall I rub this one, this part, whatever I have written on this PDF, shall I rub this one? आपने नोट एंटर किया, whatever we have written here, नोट्स में लिखा आपने? अगर नहीं लिखे तो मैं इसको वीडियो को यूट्यूब पे डालूंगा, तो आपको जहां पर आपको देखना है तो देखकर नोट्स लिखो, नोट्स आपको बनाना है। ये फिल्म देखने है ऐसा नहीं देखना है आपको, नोट्स बनाना है आपको। यहां पर मैं क्या दे रहा हूं आपको, एक छोटा सा दे रहा हूं ऐसा, CH3OH है ना, नेक्स्ट पार्ट CH3CH2OH, one more also I have take CH3 CH3 CH2 CH2OH। मैंने 3 मॉलिक्यूल दिया, पहले क्या है? मिथेनॉल, दूसरा क्या है? इथेल अल्कोहल इथेनॉल, तीसरा क्या है? प्रोपेल अल्कोहल और प्रोपेनॉल। नाउ व्हिच इज मोर सॉल्युबल? यहाँ पर पॉइंट देखो, solubility decreases with increase in the size of alkyl group here. अभी बोलो, which is having more soluble?
Methanol.
Ethanol.
First.
Why? What is the reason? You observe here what happened. You observe. This part is hydrophilic part. Correct or not? This part is actually what? Hydrophilic part. Philic means what? Loving, attracting. So OH loves what? Water. Hydrophilic, water loving, water affinity, OH part. OH part. Now जो R group है ना, R group, methyl, ethyl, propyl, this group is what? R group here. This parts, R group part is hydrophobic part. Hydrophobic. Water hating part it is. The R, alkyl group is, or aryl group, whatever it means, alkyl or aryl groups, they're water hating because they can't develop any polarity. Yet they can develop their negative charge and positive charge. That is the reason they are what? Hydrophilic. So as hydrophobic part increases, that means as carbon chain increases, solubility what happened? Decreases. Because hydrophobic part is increasing or not? Here hydrophobic part is only one carbon. Here hydrophobic part is how many here? 3 carbon. As carbon chain increases, hydrophobic, water hating capacity what happen? Increases. Therefore what happens? Solubility decreases. ऐसे भी आप क्वेश्चन पूछ सकते हैं एग्जाम में ना. Methanol, ethanol and propanol, which is having what? More solubility, whichever is having less number of carbons. Methanol is the more soluble in all comparing alcohols. Correct or not? Any doubts?
No, sir.
Up to physical property?
No, sir.
Right. Now let me see only small topic only. I don't discuss chemical properties. Already 11:45. Because of today, what happened? We got late because of this opening. Otherwise, we can complete this one also. But no problem. I will just introduce what type of chemical reactions will take place in the alcohols. Okay. Now there are two types will be there. What are they actually? When you observe here, what? When you write what happened, alcohol, ROH. So the bond may break here, one type of chemical reaction, or the bond may break here also. The bond may be breaks here also like this. So two types of cleavages will take place. One is OH cleavage. To exhibit acidic properties, it exhibit what actually? Acidic properties. When you break this bond, this is exhibited by what actually? Substitution reactions. Nucleophilic substitution reactions, isn't it? So there are what? Two types here. One is what? OH bond cleavage. OH bond. Here आपको bond break cleavage हो जाएगा. ठीक है ना? बाद में second क्या होता है? CO bond cleavage. CO bond. Here, this bond. For example, if I take what? CS3OH. CS3OH. तो bond कहाँ cleave हो जाएगा? यहाँ पर cleave हो जाएगा. यहाँ पर जनरली आपको कार्बोकैटायन, इलेक्ट्रोफाइल और कार्बोकैटायन, नथिंग बट व्हाट? इलेक्ट्रॉन डिफिशिएंट CH3 प्लस मिलेगा आपको. CH3 प्लस मिलेगा. इलेक्ट्रोफाइल आएगा. यहाँ पर आपको न्यूक्लियोफाइल आएगा क्योंकि RO माइनस आ जाएगा ना. यहाँ पर क्लीव हो जाएगा तो क्या होगा? आएगा RO माइनस आ जाएगा. Okay, so this is only I want to discuss here. So two types of reactions. One is OH cleavage, other is what? CO cleavage. In OH cleavage, what we are going to get? Nucleophile. For example, I'm writing here. Just I'm writing here. CH3OH I'm writing. So yeah, which is having more electronegative between oxygen and hydrogen beta? Oxygen. So bonding will get on oxygen. So we are going to get CH3O minus. Next one, CH3OH. CH3OH. Now between carbon and oxygen, which is more electronegative? Carbon and oxygen, which is more electronegative beta? ऑक्सीजन. तो बॉन्डिंग कहाँ जाएगा? ऑक्सीजन में. तो आपको आ जाएगा यहाँ पर CH3 कार्बोकैटायन. तो यहाँ पर आपको क्या आ रहा है? इलेक्ट्रोफिल आ रहा है. ये इलेक्ट्रोफिल और ये क्या बोलेगा हम? न्यूक्लियोफाइल. तो नेक्स्ट क्लास विल डिस्कस अबाउट द डिटेल reactions involving in the OH part. Reactions involved in the OH part. Next class we'll discuss this one. So before that, what happened? We'll give some exercise on this one. You just see that exercise also. ये आपको आज करना है. 11.4, 11.5, 11.6 आपने कंप्लीट किया, कल मैंने दिया इसको, ये भी ट्राई करो, नहीं तो मैं कल मेरे को पूछो ये हम कल करेंगे इसको, ये नहीं देखना आपको, ये आपको आज हो गया, आज ये कंप्लीट करना है आपको, ये भी हो गया, कंप्लीट हो गया, ये भी हो गया, लास्ट में हो गया, ये भी आज हो गया, 11.12 भी हो जाए, हो गया, कंप्लीट हो जाए, ऑलरेडी कंप्लीटेड गया, इज आल्सो टुडे कंप्लीटेड, यू कंप्लीट दिस वन आल्सो। यहां तक 11.13 तक आपको करना है, 11.13 तक। सो 11.13 जो राउंड ऑफ मैंने किया, 11.4, 11.5, 11.6, 11.7 ट्राई करो, नहीं तो मैं आपको प्रैक्टिस करवाऊंगा मैं कल, 11.9, 11.10, 11.11, 11.13 तक आपको करना है। सो दिस इज अबाउट द टुडे क्लास। सो इफ यू हैव एनी, stay with me, otherwise what happen, you can log out. Yes, sir. You can math, physics, sir.